This video is about Turing machines and especially about halting and accepting words. So it's about Turing machines and we consider halting and accepting. Halting and accepting. Let's take a Turing machine like this one here. We have an initial state, and at first the Turing machine can read, for example, an A, can write an A and move the head to the right, or if it reads a B, it goes to this state. Now we have memorized in the state the first letter we've read, and then we keep on and we just skip all the letters that we might have. So we go to the right, skip all A's and all B's. We do not change anything on the tape. And the same here. So we don't care what might be on the tape. And at some point we've reached the end of the input. And at the end of the input we'll encounter a blank. Okay, we'll keep the blank. And we move to the left. And now the head is on the rightmost character of our input. And now we check whether this rightmost character is actually the same character as the leftmost. So if there is an A, we just keep the A and we do not move the head and we go to an accepting state. And similarly here, if we encounter a blank, then we know we have reached the end. We go one position to the left with the head, and then we should have a B in this case, because here our first letter was a B, so our last letter should be a B. So now we have a Turing machine that accepts the language that consists of all words for which the leftmost and the rightmost letter are the same. So if we have our infinite tape here, and then we have a lot of blanks, and then our input starts, and we have, for example, an A, then B, then A, then B, and then an A, and more blanks. Then in our initial configuration, the head would be positioned on the first letter of this A. It would change to this state here, go to the right until it finds the blank, goes one step to the left, checks that there is an A, and if there is an A, it goes to an accepting state. So by this, the Turing machine can accept a specific language, our language L, which is the set of all words W1, W2, and so on till Wn, such that Wi is in the set of A's and B's, so it's only one letter here, and the first letter, W1, should be equivalent to the last letter, should be the same letter. So first and last letter should be the same. And this is the language that is accepted by final state. So here we have accepting L by final state. There's one convention we usually adhere to, and that's that here, this is the final or accepting state. So this state here is accepting, or final. And we don't have any outgoing transitions here, so no outgoing transitions. That's mere a convention, and it's useful because then we know that the Turing machine cannot do any further moves once it reaches this state. Apart from that, it's no real restriction, because once we've reached an accepting state, we know that the word is accepted, then we can simply stop anyway, because then we know we have found an accepting run. Okay, this is accepting using final state. There is a different notion for accepting words. That's more or less the original notion, and that's accepting by halting. What does it mean that the Turing machine halts? Turing machine halts if there's no outgoing transition for the current configuration. If we are at some point and there's no outgoing configuration, for example, if we were in this state here, and if we would encounter a B, so if the last letter of our input would not be an A but a B, then there would be no outgoing transition. So actually here there's no transition for the B. So here no transition for B. Similarly, here's no transition for an A. And here are no transitions at all. In all these states, the Turing machine can actually hold. In all the other states, we have outgoing edges for all the possible inputs, except here, the empty word, there is no actual outgoing edge. Okay. And the second possibility of accepting a language is by constructing a Turing machine that accepts the language by halting. That means that you start with a given word on the tape, then you run the Turing machine until the Turing machine can make no further moves. Okay, I will now summarize what we've seen here for the two kinds of acceptance. The first one is accepting by final state. This means Turing machine on input X reaches final or accepting state. That's the first possibility. This of accepting words, and this is we start with the word on the tape, and the Turing machine reaches a final or accepting state. Second possibility is Turing machine on input X halts, and this means reaches a state that has no outgoing edge, transition. For the letter under the read-write head. And in this case, the Turing machine would hold, and if we consider accepting words by halting, then this would mean that our Turing machine accepts the word. So let's see what this would mean here if we change our Turing machine so that it would accept by halting. Then there are some problems here. This one here, it's easy. Once we've reached an accepting state, the Turing machine halts anyway. So we know that once we're here, it halts. It's nice. However, there are three possible states in which there might be halting without accepting actually a word. First one is here. There's no outgoing edge for the case that we have the empty word. So we would have to add a transition, and if we encounter a blank immediately, then we do nothing, go to this state here. Here, if we encounter a B, we do nothing and move here. And if we encounter an A, we do nothing and go here to this state. This state here now is not accepting, but it would still hold. So in this case, we simply loop. So whatever we have, we don't care and we don't move the head, we just loop. So with the addition of the orange transition, we now have here a Turing machine that actually accepts the same language by halting and by final state. Because if the word is not in the language, it will always end up in this state. In this state, it will loop. If it is in the language, it will end up in this accepting state, and there's no outgoing transition, so it will halt as well.